In today's lesson, we are mastering the binomial series for rational exponents, a fundamental component of the Cambridge Pure Mathematics 3 syllabus. This topic is essential for your P3 examination, as it frequently appears in paper 3, often worth 5 to 7 marks. It bridges the gap between simple algebraic expansion and the infinite series needed for complex calculus. The general formula is as follows: 1 plus x to the power of n equals 1 plus n x plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed, and so on. When the power, n, is a negative integer or a fraction, the expansion of 1 plus x to the n does not terminate. Instead, it produces an infinite series. For the series to converge, the absolute value of x must be less than 1. This is known as the condition for convergence, or the range of validity. Let's look closer at the validity of these expansions. The series for 1 plus kx to the power of n is only valid if the variable term, kx, has an absolute value less than 1. This ensures that as we increase the powers of x, the terms eventually get smaller and approach 0. Crucially, the standard formula only works when the first term inside the bracket is exactly 1. If you are given an expression like a plus bx to the n, you must first factor out a to the power of n. Failing to do this is one of the most frequent errors in P3 exams. Let us apply this to a structured example. We want to expand the expression 2 minus half x all to the power of negative 1. First, we must force the leading term to be 1. We factor out the 2, but remember it stays inside the power of negative 1. This gives us 2 to the negative 1 multiplied by the bracket 1 minus 1/4 x to the negative 1. Since 2 to the negative 1 is 1/2, our expression is now in the correct form to apply the formula. Now we identify our variables. N is negative 1, and the variable term is negative 1/4 x. We substitute these into the general formula. Notice the careful use of brackets for the negative terms to avoid sign errors. Simplifying inside the square brackets, the negatives cancel out, leaving us with 1 plus 1/4 x plus 1/16 x squared. Finally, we multiply the 1/2 back through. This is the first 3 terms of our infinite expansion. To find when this is valid, we take the absolute value of the variable term from our modified bracket. The absolute value of negative 1/4 x must be less than 1. Multiplying by 4, we find the range of validity is the absolute value of x is less than 4. Now, let's look at a typical Cambridge P3 exam question. Expand 1 plus 3x to the power of negative 1/3 in ascending powers of x, up to and including the term in x squared. State the set of values for which the expansion is valid. We start by identifying that the leading term is already 1, and our power n is negative 1/3. The variable term is 3x. Substituting into the formula, we have 1 plus negative 1/3 times 3x plus negative 1/3 times negative 4/3 over 2 factorial times the square of 3x. Simplifying the terms, negative 1/3 times 3x becomes negative x. For the third term, the numerator is 4 over 9, and dividing by 2 factorial gives 4 over 18. We multiply this by 9x squared. This simplifies beautifully to 1 minus x plus 2x squared. For the validity, we set the absolute value of the variable term, 3x, to be less than 1. Dividing by 3, we find the expansion is valid for the absolute value of x less than 1/3. In an exam, you can also write this as x is between negative 1/3 and positive 1/3. Let's address the errors that frequently cost students marks in the P3 exam. Many students apply the formula directly to expressions like 4 plus x to the power of n without factorizing. Remember, the formula only works for 1 plus x. You must factor out the leading constant first. When you factorize, say, 4 plus x to the negative 2, students often pull the 4 out but forget to raise it to the power. Look at this common error. Notice that 4 to the negative 2 is actually 1 over 16, This mistake will invalidate every subsequent term in your expansion. When the variable term is negative, such as 1 minus 2x, students often forget to include the negative sign inside the powers. Always use brackets. Squaring a negative term must result in a positive term. Students often find the validity for the original expression rather than the rearranged one. Always use the term that is paired with the 1 inside the bracket for your modulus inequality. To finish, here are some critical tips for your Cambridge P3 examination. In the mark scheme, there is often a method mark for the correct substitution into the binomial formula. Even if you can simplify in your head, write down the full expression with the factorials and brackets first. This protects your marks if you make a mental arithmetic error later. Check the question for the required number of terms. Cambridge questions usually ask for the expansion up to the term in x squared or x cubed. Do not waste time calculating more terms than requested. However, ensure you don't stop early. Up to x squared means you need the constant, the x term, and the x squared term. Be precise with the range of validity when asked for the set of values for which the expansion is valid. Always use the modulus notation or an inequality. If the question asks for the range of validity, writing the absolute value of x is less than k is the most efficient way to present your answer. Watch for partial fractions. In P3, binomial expansion is often the second half of a partial fractions question. You will be asked to split a complex fraction into simpler parts and then expand each part. Always check that your individual expansions have the correct leading one before you combine them.